Hello everyone, welcome to Gate Academy. So in this session, we will discuss bitwise right shift operation. Bitwise right shift operator. So the symbol, okay. Let's learn bitwise right shift operator. Sir, the very first thing we need to understand is, sir, it is a binary operator. That means it requires two operands to work upon. Okay. Sir, what does that mean? If I say 5 right shift 1, what does that mean? Sir, shift to the left or to the right? Right shift. 5. How many times? How many times? Sir, one time. Right shift operator has two operands. The value in the left side tells us on which operands we are applying the right shift operator. And the right operand or the second operand tells us how many times we must right shift this particular operand. Just like left shift operator. That means, sir, what is the meaning of this? We are saying right shift 13, how many time? One time. Sir, if I write something like this, what does that mean? Right shift 14, how many times? 3 times. So that's the basic meaning of binary operator. Sir, it requires two operands. Okay, let's quickly start with a question. Sir, hash include is stdiu.h void main int x is equal to 5 y. Let me right shift x one time and print the result. Sir, it is a binary operator, but bitwise operator. That means the very first thing we need to do is, sir, find the binary equivalent for 5. Let me calculate. Sir, 5 successive division by 2, store the remainder. So when 5 is divided by 2, it goes 2 times with the remainder 1. When 2 is divided by 2, it goes 1 time with the remainder 0. When 1 is divided by 2, it goes 0 times with the remainder 0. With the remainder 1, we need to stop. Sir, the binary for 5 is 101. Let me remove this. So, the binary for 5 is 101. Sir, I am assuming again that integer takes 2 bytes or 16 bits. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 101, 3 bits. All the remaining bits will be 0. All the remaining bits will be 0. Sir, what we want? This is x. Sir, we want to right shift it one time. What is the meaning of right shift? Assuming something like this, that we are pushing all the bits from here, what will happen? Sir, this bit will be popped out. This bit will be popped out. And all remaining bits will be shifted by one position to the right. That means, sir, Let me again. Very easy operation. Everyone can understand it easily. Sir, if this goes popped out, this will shift from here to here. That means 0. This will shift from here to here. That means 1. This will shift. That is 0. 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 Sir, 0, 0, 0, 0, 0, 0, 0, 0. Sir, as we are shifting towards right, when we used to shift at one time, there will be a space, empty space created in the right hand side. No, sir, in the left hand side. We are shifting to the right. That means where will be the empty space? To the left. So, sir, this empty space is filled by a 0. Sir, this empty space is filled by 0. So, what is the answer? Let's see. Sir, this is the binary. Okay. Sir, these all the bits are 0. We need to focus on 1, 0. Sir, it is 2 to the power 0, 2 to the power 1. So, the decimal equivalent is 1 into 2 to the power 1 plus 0 into 2 to the power 0. That means it is 2. So, if I right shift 5 one time, what is the output? Sir, we are getting 2. So, the output is 2. Let us solve few more questions so that you must have clear idea about what is going on. Sir, hash include stdio.h void main int x is equal to 10 y. Let us right shift x 2 times and print the result. Okay, let us do this. Sir, okay, sorry. Done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Sir, first we need to find the binary equivalent for 10. So let me find it. Sir, the binary equivalent for 10, if I divide it by 2 and store the remainder, sir, it goes 5 times, the remainder is 0. If I divide it by 2, the quotient 5 is divided by 2, it goes 2 times with the remainder 1. If I again divide 2 by 2, it goes 1 time with the remainder 0. And if I divide 1 by 2, it goes 0 times with the remainder 1. So the binary equivalent for 10 is 1010. The binary equivalent for 10 is 1010. Sorry, 1010, and all remaining bits are zeros. So done. When I right shift it one time, see, we need to right shift it 2 times. When I right shift it one time, this bit goes out. This will be popped out. And if this will be popped out, sir, this space is occupied by this space is occupied by this. That means all remaining bits are shifted to the right by one position. That means this one used to come here, this 0 used to come here, this one used to come here, this 0 used to come here. Sir, all remaining are shifted by one position to the right. That means 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And we got an empty space in left hand side. Sir, this empty space will be filled by 0. This empty space is filled by a 0. Sir, what is the new value? Let's try to find out. Sir, these all are 0. That means focus on 1, 0, 1. So it's 2 to the power 0, 2 to the power 1 and 2 to the power 2. So 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. Sir, 4 plus 0 plus 1, that is 5. So, sir, previously it was 10. When I right shifted it one time, it became 5. Let me right shift it one more time. Sir, if I right shift it one more time, this bit will be popped out. And all previous bits are shifted by one position. That means this 0 come here, this 1 will come here. 0, 1, then 0, this bit. Okay. Sorry. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and empty space is filled by 0 again. Empty space is filled by 0 again. Sir, what is the value? What is the value? Sir, we need to focus on 1, 0. 2 to the power 0 and 2 to the power 1, which is 2 to the power 1 plus 0, that is 2. So that means, sir, 10. When I right shifted it one time, it becomes 5. 5, when I right shift it one time, it becomes 2. Okay. So can I say divide by 2? Yes, of course. 10 when divided by 2 will give you 5. But 5 when divided by 2 will give you 2.5. Sir, that means 2. Sir, how things are working? Let's see. Sir, we have 10 as 1010. We have 5 as 101. We have 2 as 10. Try to understand. In the previous session, I already talked about something that if I have any binary number and if I append a 0, if I have any binary number whose value is x, if I append a 0, its new value becomes 2x plus 1. 2x plus 0, sorry. Or I can say 2x. And if I have any number whose value is x, and if I append a 1, its new value becomes 2x plus 1. Sir, even and odd. See, 2x is always even and 2x plus 1 is always odd. Think it in reverse way. Sir, if I have any number, either the last bit is 0 or the last bit is 1. If I right shift it, this bit will be popped out. And the empty space is filled by a 0. Sir, if the rightmost bit is popped out or deleted, then what is the new value? See. The previous value was x. That means, sir, if it is 2x, still the value is x. If it is 2x plus 1, still the value is x. So if it is even, okay, that means if the value is 10, sir, that means 1010. If it goes off, the value becomes 10 by 2, that is 5. If it is odd, sir, it does not matter how 5 is constructed previously, how we can construct 5, sir, 2 and appending a 1. That's how we can find, that's how we can construct 5. That means 2 into 2 plus what is the bit appended. So if you delete this, what you get? Sir, 2. So if it is odd again, what you get? Sir, you will get 2. So try to understand. What if I say 15 right shift 3 times? Sir, 15 by 2 is 7. Okay. Sir, if it is 7, shifted 1 time, you will get 3. Sir, again, if it is odd, you will get a 1. So don't think 1.5, don't think 7.5. So that's how right shift operator used to work. So can I say for every positive integer, sir, what is the meaning of this? You are saying divide 15 by 2 into 2 into 2, that is 3 times. So can I say 15 divided by 8? Sir, the answer will be 1. That is, integral value is 1. So, sir, right shift operator, if I say x, right shift x n times, what does that mean? It is as same as divide x by 2 to the power n. I am working on positive numbers only. And if I am saying, what does that mean? Multiply it 2 to the power n time. We are only working on positive number. Sir, can we perform left shift and right shift on negative number? Yes, we can perform, but the result is completely undefined. That means, sir, don't ever try something like this. Sir, can we shift it negative number of times? No, don't try. If you try, I don't know. The behavior is undefined. The behavior is undefined. Sir, can we do something like this? Again, no. I'm not saying no, that means you cannot do that, but the behavior or result is completely undefined. As per C standard, the result is undefined on negative numbers. Similarly, sir, don't do something like this or don't do something like this. Because on some compiler, when you try to right shift a negative number, the empty space is filled by 1. But on some compiler, the empty space is filled by 0. So the behavior is completely undefined. So what you need to know as per gate, that what is the behavior of left shift operator and right shift operator when working on positive numbers. So that's all for this session. Bye-bye. Take care.